So we said in an earlier video that demand curves slope down, right? As the price decreases, the quantity demanded increases, and as the price increases, the quantity demanded decreases. Um, but that doesn't tell us how much the price changes due to a change in quantity or how much the quantity changes due to a change in price. And so in order to figure that out, which is going to be very important for a firm's pricing and output decisions, we need to calculate something called the price elasticity of demand. Now, one thing that you should always remember for all of your economics classes is that all elasticities are just a percent change divided by a percent change. And the reason that we do a percent change is so that the units that we're measuring in don't matter. So it doesn't matter whether we're talking about, you know, quantity in terms of units or dozens or thousands, or price in terms of dollars or euros or yen. We take all of the units out, and so we're just talking about percent changes. And so the price elasticity of demand is perhaps the most common elasticity that we'll talk about, and it is the percent change in demand divided by a percent change in price. And now that number is always going to be negative because as the price goes up, demand goes down. And so the numerator and denominator will have different signs. And so, but we always report it as a positive number. So it's really the negative of the percent change in demand divided by the percent change in price. So that's given here. And so let's just do some examples with this demand curve that we've been working with. And now remember, the percent change is the change in quantity divided by the original quantity. That gives us the percent change in quantity. And then the percent change in price is the change in price divided by the original price. So for instance, at point A, when we go from 20 to 21, well, the change is just 1. The original amount is 20, so 1 divided by 20 is 0.05 or 5%. That's what we get here. And then the percent change in price is the change in price, which is 80, divided by the original price, which was 6,400. And so that's 1.25 or 1.25% or 0.0125. And so in order to get the elasticity, we divide the percent change in quantity, 5, divided by the percent change in price, 1.25, and we get 4. So in this case, at point A, the demand curve has a price elasticity of 4. Now, at point B, now we're at 40. Now a 1 unit change in quantity is no longer 5%, right? Because 1 divided by 40 is not the same as 1 divided by 20. And so now it's 2.5%. And so that's our percent change in quantity. And the percent change in price is 80 again, right? We have a straight line, and so the slope is always the same. But now it's 80 divided by 4,800, or 1.67%. And so now when you calculate the elasticity, it's 1.5. We can do the same things at point C and D. At point D, we get an elasticity of 0.43, and at C, we get an elasticity of 1. And so this elasticity of 1 is sort of a special point. We call it unit elastic. Basically, it means that the percent change in quantity and the percent change in price are the same, and so they just balance out. Over here at points A and B, we say that the price elasticity of demand is elastic because it's greater than 1. And at point D, we say it's inelastic because it's less than 1. So this price elasticity of demand is going to be very important in terms of how firms choose their profit maximizing price and quantity when they have a downward sloping demand curve. And what we'll find, what you can prove, and you can go through the math, or you can take my word for it at this level, is that the firm's markup, and so the markup is just price minus marginal cost, is greater when demand is less elastic and smaller when demand is more elastic. So if you were eyeballing different demand curves, the flatter a demand curve is, the more elastic it is, and the steeper it is, the less elastic it is. And so when demand is very inelastic, the more inelastic it is, the more that firms can charge above their marginal cost, which is their markup. And so that kind of makes sense, right? Because if something is really inelastic, it means that a change in price has only a small change in quantity demanded, in which case firms will be able to increase their price a lot without reducing the quantity demanded a lot. On the other hand, if we're over here and we have a really elastic demand curve, that means a change in price will lead to a large change in quantity demanded, and so firms will not be able to mark up above marginal cost very much. And so this markup is going to be really important, right? We'll see in the next chapter, in chapter 8, when we have perfect competition, firms can't mark up at all because basically they face a flat demand curve mostly because the things I'm selling are exactly like the things my competitors are selling, and so I have no market power. But in the real world, for most firms, they do have market power, but that market power depends on sort of how differentiated their product is compared to their competitors. Now, if you are a government and you're putting a tax on certain goods, then if you want to raise a lot of money, you want to put a tax on inelastic goods, right? On those more vertical demand curves, because it won't change the quantity demanded a lot and you'll collect a lot of tax. Rather than a demand curve that's fairly flat, because then it will change quantity demanded and you won't collect a lot of tax. But another thing that you might want to do is to put a tax on things that really aren't that good for people, right? Things like cigarettes and alcohol. And more countries and cities and states are experimenting with putting taxes on things like sugary drinks, because there's a lot of evidence linking sugary drinks to obesity, which increases costs for healthcare systems, and so it might make sense to tax that. This table just gives you some price elasticities of demand for different goods. So fruits and vegetables are a little bit over 1. Here, uh, I'm not sure what the different categories is, maybe canned versus fresh. Grains and pasta are a little bit less than 1 here. And so you can get an idea of sort of general elasticities.